Widmeyer. We're going to jump right into things here because I realize that my videos are too long. This is the fourth time I'm taking this video and they've all been too long. So you can imagine I spent an hour here trying to just create a 10-minute video for you. So it's kind of lame, but here we go. All right, so I'm going to really try and pare down all the information that I'm going to show you guys here, okay? I'm going to give you guys kind of like an exercise for you guys to kind of explore here on your own, and then I'll just kind of summarize things too. All right, so we were in the polynomials unit. Today we are going to start graphing polynomials, and we're going to look specifically today at end behavior. Okay, and how to determine that by looking at the standard form or any function of a polynomial, any function to find a polynomial. So the end behavior, okay, how to do that? Well, so what I would ask you guys to do is to sketch a graph of the following polynomials. Ooh. Sketch a graph slash identify the end behavior of f of x equals, and I'm going to give you 6 for you to try. Now, you don't have to write out all the end behaviors if you don't want to. There's a lot here, but at least think about what you would define the end behaviors to be. Okay, then once you sketch those out, I also want you to do the same thing. I want you to then sketch, again, but now do negative x squared, negative x to the third, negative x to the fourth, negative x to the fifth, and negative x to the sixth. Okay, now when you throw a negative in front of your function, right, think about what kind of transformation that does. Okay, so go ahead and pause the video and do that. Okay, hopefully you pause the video. If you don't pause the video when I ask you to pause the video, you're going to have a more difficult time learning this stuff because you actually have to try it on your own, okay? You are also welcome to use a graphing calculator here to help you with this. I didn't say that, but that's okay here too, just to get quick sketches and stuff like that, okay? And again, the end behavior, you don't have to write it out. We're just looking for a pattern here. So here we go. I'm going to quickly sketch these out. Okay, here's what they look like. We already should know quadratic and cubics from a previous, previous unit for quadratics and cubics. We did those earlier this unit. Okay. I don't even bother doing the arrows because we're just going to have no time here. Okay, so there's those. You might notice some similarities here between the odd degrees, right, and the even degrees. All of their end behaviors are the same, right? So the even powers all have the same end behavior. Likewise, the odd powers also all have the same end behavior, okay? Similarly, if we sketch these, you should have gotten something that looks like this, 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 and then negative x to the fifth, and then negative x to the sixth. Okay? And the same patterns occur again. The odd degrees all have the same end behaviors, and the even degrees also all have the same end behaviors. The end behaviors are now the exact opposite of their positive lead coefficient partners there. So how can we summarize this? In general, then, we can put this all in a table. Okay. And we can say, we need to know 2 pieces of information to identify the end behavior. The lead coefficient. Oops, actually I'm going to do that. Oh boy. We'll do the degree here of the polynomial. And again, just even or odd is all we need. And then the lead coefficient. I'll make a little table here to organize this. Okay. So there's our table, right? So if we look for even degree lead coefficient positive, that'll take us to these green up here, right? These guys, right? This one, this one, this one. And what's their end behaviors? Whether you go x approaches infinity or whether x approaches negative infinity, whether you go far right or far left, you're going to go up in both cases. So as x goes to infinity, f of x goes to infinity. And as x goes to negative infinity, f of x goes to negative infinity. Nope, x goes to infinity. They both go to infinity. Okay, so the end behavior looks something like this. Okay, I put little dot dot dots there to indicate that we are not sure what happens in between, but we know for sure what happens at the ends. Okay. Oh shoot, I just realized that I put those things in the wrong. Here's how I'm going to fix this. Positive lead coefficient, negative. There you go. Sorry, after doing this a couple times, I've moved myself around there. Okay, now that's right. Positive lead coefficient, even degree, this is what we get. Okay, now, even degree negative lead coefficient, well, that just reflects it over the x-axis, and we get something that looks like this, right? Okay, so as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x will also approach negative infinity. And again, our end behavior looks something like this. Okay. For odd degreed functions with a positive lead coefficient, well, that's going to be like your x cubes, your x to the fifth, your x to the first, right? Because that's x to the 1 right there. Ooh, no, it's not. Okay, like that. So what happens there? Well, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x will approach negative infinity. Okay, and that's going to be the end behavior that looks like this. Okay, where they go different directions each place. All right. And then finally, for an odd negative lead coefficient, that's going to be these guys right here. These guys right here. Okay, so we'll just go down here. As x approaches infinity, f of x will approach negative infinity now. And as x approaches negative infinity, f of x will approach infinity. And so our end behavior is going to look something like this. Okay, so let's do some examples here then. Okay. Okay, so what is our degree here? Degree is 3, which is odd. The lead coefficient, a, right, equals 1, which is greater than 0. Okay, because there it is right there. Okay, and so what does that mean? Well, we have odd degree, positive lead coefficient. So odd, positive, we're going to get this right here. Okay, so end behavior would be as x approaches infinity, f of x will approach infinity, and as x approaches negative infinity, f of x will approach negative infinity. Okay, try another one. At any point, feel free when I write the problem out for you guys to try this on your own. All right, let's try negative 4x squared plus x to the 4th. Okay, the degree of this one is not 2. Be careful. The degree of this one is 4. This is not in standard form. If I wrote it in standard form, you would see it written this way, and then you can see there's that 4. Highest power is the degree. So that's an even degree. Our lead coefficient here again is 1. So a is 1, which is greater than 0. So as x goes to infinity, f of x will go to, well, again, even degree, positive lead coefficient, even, positive, that's this right here. Okay, so infinity. And as x goes to negative infinity, f of x goes to infinity. All right, now, sorry, one more. F of x equals 2 minus x times x plus 2 times x plus 3. Okay, so if you look at this one, this is not in a format that's going to help us find the degree, right? Because we don't know what the degree is, it's not multiplied out. So you could multiply this all out, and that's one option. However, we know that when we multiply this out, we only really need to know what the highest power is going to be and what the lead coefficient is going to be. So if you look here, the highest power here is that x, the highest thing here is an x, and the highest thing here is an x. So we'll have an x times an x times an x, so it'll be x to the third. And their lead coefficients, well, we have a negative x times a positive x times a positive x, so negative 1, x to the third, and then we'll have some other junk. We don't care about the other junk, we just care about what the degree and what the lead coefficient is. So the degree is 3, the lead coefficient is negative 1, which is less than 0, so that's going to be odd, less than 0, so that's this situation, okay? As x approaches infinity, f of x will approach negative infinity. As x approaches negative infinity, f of x will approach infinity. Okay, so this is all I want you guys to do for today. You can also check your answers using your graphing calculator. If you just graph either of these, this function right here or this function right here on your graphing calculators, you can see what they look like to check your end behavior results. So yeah, if you have any questions, please make sure to post them in the comment section of the updates page on Schoology, for the pertinent, lesson. So good luck.